Now let's look at learning objectives D and E together. We're going to understand that complex zeros actually occur in pairs and also verify that a value is a zero of an equation. Now there's a very key theorem here. It's called the conjugate zeros theorem. And what it says is if the complex number a plus bi is a zero of our polynomial, then we are guaranteed a minus bi is also a zero. That is, imaginaries travel in their conjugate pairs. The reason this happens is because when you solve within the quadratic formula, the plus or minus in it is where the conjugate pair actually comes from, by the way. So let's just look at one example. Here we have a third degree polynomial. I'm guaranteed there's exactly 3 zeros for this. By the way, I graphed it in the calculator, and it looks like there's at least one real zero. It's right in here. I can't exactly tell what it is. I looked here at the table and I was trying to find if there was a value and y zeroed out and an integer, and I didn't see one. So it looks like it's a fraction. So this actually doesn't help me get really any answer, but it does let me know there's one real zero. Now, I'm wondering if that real zero happens 3 times, or could there be a pair of imaginaries? Now, part A is telling us that 2i is a zero, which means there is an imaginary answer. So let's actually start this. There's 3 zeros. They're telling me that one of them is 2i. Because I know one is 2i, they travel in conjugate pairs, so I am guaranteed the other answer is negative 2i, which means there's one more answer left, and I know that answer is real, so I have to be able to find it, and we'll get there in a second. So let's do part A though and first verify that 2i is an answer. So all I'm going to do is put 2i in for x and simplify. And when we simplify, remember, it should come back to equaling 0. So we have to be a little careful on this one. And then minus 8. So let's go ahead and talk through the PEMDAS first. Exponents first. 2i times 2i times 2i is going to be 8i cubed. So if this is 8i cubed, I'm going to do 8 times 3 and do 24. So 24i cubed. This here is going to be 2i times 2i, which is 4i squared. Then I'm going to do 4 times this and get negative 8i squared. 2i times 12 is plus 24i, and then minus I. Now one thing we remember is I squared should be replaced with negative 1. But be careful, there's actually an I squared in the I cubed. I cubed is actually made up of I squared times I. So what I need to do is peel out one of the I squareds. So I'm actually going to rewrite that first as 24 is I squared times I. We'll come back to it. Let's do negative 8 and change the I squared to negative 1 plus 24i minus 8. Let's go ahead now and let's change I squared to negative 1. So this will just become equals to negative 24i. This here becomes plus 8 plus 24i minus 8. When we simplify this, negative 24i plus 24i is 0. And 8i minus I is also 0. So we just verified that 2i is a 0 of this function. Now, part B says find the remaining zeros. Well, we know it's a third degree polynomial, so there's 3 of them. They gave us the first one. We know the second one because they travel in complex conjugate pairs. Now we need to figure out what the third one is. And I'm going to carry this problem over into learning objective F and talk about how to do that.